This morning, I'd like to give you an update on our non-proprietary technologies for removal of nitrogen from on-site residential wastewater. You'll see some overlap, and so I will be brief in some of my opening comments, but things have changed a lot in the last 75 years on Long Island. The human population has increased by 7 times. The duck population has virtually collapsed, but we've transitioned from an agricultural economy to a more suburban economy. Humans, ducks, or human waste, duck waste, and fertilizers from agriculture all create excess nitrogen in their environments, but the net on Long Island in the last 75 years has been an increase of nitrogen loading to our groundwater, which, as Chris describes, cycles through our aquifers of 5 times. Unlike in Nassau, where most of the communities were planned and most were sewered, in Suffolk County, we grew without sewers, first with cesspools, and later from the 70s with septic tanks and leaching rings. So there's 360,000 roughly residents in Suffolk County that have these technologies that don't remove nutrients, either phosphorus or nitrogen. And Chris explained the water cycling already, from the drinking water estuaries to our marine environment. About 2/3 of the nitrogen entering those environments is from septic residential wastewater. That not only affects our estuaries, but also our drinking water wells, and our wells, before they're mixed, have some of the highest average nitrate concentrations. This map on the right here indicates nitrate in tap water, and you can see that there's some places out on the North Fork and in the Huntington area, Southampton area, where we're over 4% milligrams per liter. The EPA limit is set at 10 milligrams per liter. That's for a blood disease, and that regulation was passed decades ago. More recently, there's been a lot of epidemiological work which indicates correlations between lifetime exposures to nitrate and various cancers. And these epidemiological studies have been done by the Iowa Women's Health Center, and also in Europe, where they keep track of this kind of information. And those correlations exist at 3 milligrams per liter. But I want to emphasize that this is lifetime exposure. So I'm not suggesting that we shouldn't drink the water out in restaurants in Greenport, not like that. But we also shouldn't ignore it. Lee did a great job talking about eutrophication, and so I'm just going to cut through this slide, but just to say that we've had lots of incidences of harmful algal blooms, which Chris described, and fish kills, as the algae that comes from this over-fertilization dies and sucks the oxygen out of the water. We also, on Long Island, have excess fertilization creates taller plants in salt marshes, and then when they die and they fall over because they're larger than the natural salt marshes, you create dieback of those salt marshes, which we found out what the consequences of that was in Sandy. The really positive news here is that Suffolk County has responded to this situation in a very responsible and comprehensive way with subwatersheds wastewater plan, which Peter Scully, one of our guests here, was instrumental in pulling together. And the accompanying legislation, the Article 19 legislation, has now produced 7 systems commercially, which are available for commercial use, which lower very, very high nitrate levels in wastewater in Suffolk County down to below 19 milligrams per liter. The chart in the middle, upper middle here shows that we have about over 20 milligrams per liter higher nitrate than the national averages here. So these take wastewater from about mid-80s nitrate levels down to under 19, which is a major accomplishment that Suffolk County should be really proud of. So now, having gone through the background, I'd like to just talk about some of the center's technologies. They all share and work on a common principle, which is biological nitrification, denitrification. And they do that through filtering wastewater through a sand bed, which nitrifies, and then through a sand and wood chip layer for denitrification. All of those systems operate with a septic tank, a pump chamber, but then the biofilter itself, we have different configurations which control the hydraulics. So one of them, the most basic one, is an unlined NRB, nitrogen removing biofilter. And the effluent from that system goes directly to the environment, directly to groundwater. You don't need to invest money in leaching galleys or leaching rings with this system. On the other hand, what we've found is that the periodic intermittent flows of wastewater as it's dosed to the system, denitrification is less efficient with that, and there may be preferential flows that develop. That system, we now have a revision of that system with design modifications, which I'll talk about briefly momentarily. Our line system requires final disposal, leaching rings, but the wood chip biofilter is lined, so we know the volume, we know the residence time, we can control it so it's continually saturated, and you want continual saturation because oxygen and denitrification do not go together. You need an anoxic environment, which this creates very well. It's achieved provisional permitting last year, and we're in the process of organizing financing for another 12 installations so that we can start general use in the near term. Similar situation with our wood chip biofilter, and we're expecting to finish pilot testing for provisional use this month. And we have over 20 of these systems in Suffolk County now, with additional systems that we've installed in collaboration with Indian Health Services at the Shinnecock Nation. The performance has been pretty good. Our lined nitrogen NRBs are getting about 13 milligrams on average in final effluent. That's about an 83% reduction. Our wood chip boxes, and these are numbers we've calculated recently going through April, are even lower, down to about 7 milligrams per liter, or over 90% removal. The lines are up in the mid-20s with about a 2/3 removal, which is why the unlined, which is why we need to work on them a little more. And as Chris mentioned, they don't just remove nitrogen. A student here, Tricia Clyde, did a lot of work getting her PhD on studying how they remove organic contaminants that are in pharmaceuticals, that are in personal care products. And what she found was that removals in the NRB has actually exceeded removals in municipal treatment plants. And that, very importantly, that removal occurs via biological transformation. It's not just adsorbed to the sand beds in the NRBs. Often get the question, well, great, but how long are these systems going to last? Don't the wood chips run out of carbon? So we installed a line system and a wood chip box NRB up at the Massachusetts Alternate Septic System Testing Center when the center first started out in 2016. So it's coming on 8 years. And the blue line here is the influent levels at mastic, and the orange line is the effluent, total nitrogen in effluent. And it increased for a while, but it was increasing because we were ramping up the loading rates in an experiment to see how far we could ramp them up before the removal deteriorated. And so we kind of found that out and decided to stop doing that. And since then, they've stabilized and come down. And so this is 8 years. Folks up at the University of Waterloo put some similar systems in ground in the mid-90s. Published an article after 15 years, which showed they were still working, and anecdotal evidence suggests that they're still working. So decades is the answer to that. As long as you keep them anoxic, that's the really important thing. Wood chips last, and they work with what's called BOD from the wastewater itself in combination to supply carbon for denitrification. So we want to try a few new ideas, not just continue to test our old ideas. So all of the Article 19 approved systems in Suffolk County right now rely on pumps. They rely on electricity. And that's not a bad thing. Those pumps work very well. But can we do it without incurring electricity charges for homeowners on Long Island? Not in most of the commercial systems, because they're what's called plug-and-play systems. You dig a hole, drop in a box, connect it to the house and to the final disposal, and you're done. But our systems all work, as I said, with a septic tank and a drain field. So can you put in between those a gravity device? So that gravity device is called a septisurge. The way it works is upstream of that gravity device, you have columns which store your septic tank effluent. When the water pressure in those pipes reaches a certain level, it triggers a mechanism in the septic tank, and all that water flushes at once. You need that big flush. We're talking about 25 gallons or so to fill up all the effluent lines in that drain field. The reason is you want to spread that evenly over the entire drain field. You don't want it preferentially flowing. So Indian Health Services, in combination with XCAV, installed some of these septisurge devices in some of their unlined systems we were working with them on. And this is early days. It's only 5 months or so worth of data, but some of the results are good. 5 out of 7 systems are getting nitrate levels in unlined systems below 10. And I mentioned earlier that our unlined systems haven't performed as well as our lined or wood chip box systems because of the lack of saturation of the biofilter. So what can you do about that? So we're working, again, with the system up at Mastic to slow the wastewater percolation through the system down, to increase the residence time, to increase the amount of time for treatment, for denitrification. And the way that we do that is we're interspersing every 6 inches underneath the sand layer, 6 inches of sand and wood chips for denitrification, then 2 inches of pea stone, 3/8 pea stone, and we're repeating that process. The idea is that the discontinuity there between the sand and the pea stone creates a capillary rise in the sand, slowing the residence time. The pea stone also is more permeable than the sand, so it will flow laterally to increase the evenness. how are the results of that experiment done? Well, we've been running it since last summer. And initially, I should say the control here is a unlined NRB versus the multi-layer system. So we're running it at Mastic type wastewater levels, which is about 45 milligrams per liter of nitrogen in the wastewater, and we weren't seeing much of a difference. So in March, we virtually doubled that number to Suffolk County-like nitrogen levels at around over 80 milligrams per liter. And it's early days. I don't want to tempt the fates here, but results so far are promising. The multi-layer shows more reduction than the unlined control. Wood chip biofilters can also be used as polishing steps and to further clean IA systems. So back in 2020 in East Hampton, we installed 2 systems which attached a wood chip box to an IA system. And in one case, the IA system was working very well, and we were able to remove nitrate further, polishing it. We got about a 40% reduction. In a second instance, the IA system wasn't working well, but the biofilter functioned as a fail-safe mechanism, and we got pretty much just about the same final nitrate in solution. I should say the center has grants to install 16 of those because, of course, n equals 2 is not a sufficient data set to prove the concept. So we intend to have more data in the coming years on this, this approach. There's a lot of what are called pressurized shallow drain fields that get installed in areas with shallow water table on Long Island. And in 3 out of 4 cases, in order to put one of, and that's as a final disposal polishing step, in order to put those in, most of the times, in 3 out of 4 times, they actually have to remove the indigenous natural fill that's there and put in new fill. Well, the question is, if you're doing that, can't you mix wood chips in with it, since you've already had to excavate and had to bring in new material? Just bring in some more wood chips. And so that could be a very inexpensive way to go, and that's very important here. So in collaboration with DHS, and we're very grateful, Suffolk County Department of Health Services, we're very grateful. They have a grant to do about 20 of these projects, and we're going to test different design ideas for the PSDs with wood chips. What wood chips work best? It's kind of an obvious question, and we needed to answer that since we're putting in a lot of wood chip biofilters. And so we designed an experiment about 2 years ago with influent nitrate at different levels. And the answer, in short, seems to be that oak, which is pretty available on Long Island, works better than the others. We tested cherry, oak, pine, and upstate hardwoods. That's a commercial brand. But that experiment continues to see if the conclusion changes over time. There are over 100,000 septic tanks with leaching rings in Suffolk County. This is from the subwatersheds plan. So some of the systems that I've discussed address those sites. We have the wood chip biofilters as polishing units. For the IAs, we have lined wood chips and some other systems, NRBs, to replace cesspools. But we've got over 100,000 septic tanks and leaching rings. Can't we use that infrastructure to remove nitrogen? Is it cost effective to do it that way, rather than bring in a whole new system that we might have imported from Japan or somewhere? And so this experiment that we put together attempts to answer that question. So it, again, revolves around nitrification, denitrification. And one of the big questions was, are those leaching rings big enough to include a biofilter, a wood chip biofilter? And we talked to various people in the industry, and the configurations, of course, of these installed technologies, that leaching rings are different in different cases. But in just about all the cases, the numbers that we ran showed that we can put a biofilter in and have plenty of space for leaching, plenty of volume. The bigger question for us is, can we nitrify in that septic tank? And so that would be through aeration. And basically, we do what you do in a fish tank. You create a circular flow. And you see that in the blue, there's the column there. That's filled with little chips, which nitrifying bacteria use as a substrate. And you cycle the air creates a water flow that cycles water through the column. And so we did that at our wastewater research and infrastructure facility up near the university. And that's on the left there in the green column. That's a column. It's on a rail, so we can easily change out those media where the nitrate producing bacteria grow. And then there's a septic tank, and it goes to the wood chip box. We started it in the winter so we could work out the hydraulic bugs in the system. When the weather warmed up in May, it started to nitrify. We may need to change out those filters. That's the purpose of the experiment, find the optimal filter. Lee already did a great job justifying reuse and recovery of nutrients. Our solution here is a really Long Island specific situation. But the way that works is you collect urine in a no-flow toilet or urinal, and then you need to pasteurize it to disinfect it, and our center has one of those, and then you apply it and you don't need to apply it on food. You don't need to have to go through the FDA. On Long Island, we have a huge turf grass industry. The question is how you apply it. So there's a lot of good reasons for doing this process. Most of the nutrients in urine, municipal wastewater, for instance, about 85% of the nitrogen and 55% of the phosphorus is contained in 1% of the municipal urine. If you use these dry toilets, well, then you don't have to use valuable clean water from our aquifers. And as Lee already pointed out very sufficiently, these are valuable chemicals. But the real savings for our county is that you don't import nitrogen or phosphorus in synthetic fertilizers. You don't have to pay money to bring it into the county. You keep the nutrients within the county. New York State Department of Agriculture in 2009 came up with an estimate, and it's almost 4,000 tons of nitrogen a year that we import into the county. If we assume that we converted all those 360,000 houses to IA systems, the amount of nitrogen that you're going to save, whatever that estimate is, this importation of synthetic fertilizers is on the same order of magnitude. Depending on your numbers, it's a third or a half of what you would save. So it's very important to address this through nutrient recycling. In a lot of areas of the US, they can't do this because there's a long way, transportation-wise, between your urine source and your use. Not here on Suffolk County. And in Suffolk County, there's a lot of public restrooms which can be used as sources of these nutrients. So, and in fact, some of the New York State public parks at beaches are under court order to collect urine and have installed these urinals. But hauling that to a wastewater treatment plant is a waste, and it doesn't stop the importation of the nutrients in synthetic fertilizer. On the demand side, there's a lot of good news here because, one, we're a major producer of turf grass. Two, we've got over 100 golf courses on Long Island. And three, despite efforts of some to encourage natural lawns, people on Long Island still like their fertilized lawns. So the question is, can we produce a good fertilizer? And I was really impressed with Lee's numbers. And we're in the process of using different materials, more with an emphasis on both nitrogen and phosphorus. Right now, we're testing just straight aqueous application to see what those numbers look like in terms of the biomass of the turf grass that's produced, and in terms of how much nitrogen or phosphorus leach out into the groundwater. But we're also, because direct fertilization isn't for everybody, we're trying to capture that on materials, on particularly zeolite right now, and organic materials. The idea is to find the best material for removal, the best material for retaining the nutrients, and the best material for bioavailability. So those are all things we're investigating. We have a poster. I'm not going to go into the details now. This is just one experiment that shows the aqueous application. Turns out, and we're still running this experiment, but on some initial observations, the urine does as well as the commercial fertilizers, and it does a lot better, both of them do, than no fertilization. So with that, thank you very much.